So let's solve our question number 15 now, which is matrix diagonal sum. So let's move to the question. So the question says that we are given a matrix and we have to calculate the diagonal sum. So the diagonal sum looks something like this. These three plus these. Okay. So let's understand. So first of all, I'll create int n is equal to mat dot length. So in n I have stored the number of rows in my matrix, and now in m I'll be storing the number of columns. So by doing this you get the number of columns in a matrix. Okay, now I'll make a for loop. First of all, let's define our sum. Okay, let me tell you why I've done like this. Okay, so we can see that in our first diagonal, which is this diagonal, the primary diagonal, uh, the sum is something like this. Sum is equal to sum plus I comma I. Okay, so I comma I. So let's say our I is equal to 0. Let's make another variable. Primary diagonal sum. So let's calculate the primary diagonal sum first. Answer at 0 comma 0. Okay, answer at 0 comma 0. So this is 1 plus, now I becomes 1. Answer at 1 comma 1. So 1 comma 1 is this becomes 5. 1 plus 5, I becomes 2. So answer at 2 comma 2. Okay, plus 9. So this is how we will get our primary diagonal sum. So we are done with our primary diagonal sum. Now let's see how to calculate the secondary diagonal sum. Okay, so secondary diagonal sum is something like this: 3 plus 5 plus 7. So let's see how to achieve it via coding. So we will write something like this: sum plus is equal to answer at I comma n minus 1 minus I. Okay, so let's see now. Now I is equal to 0. So our sum will be answer at I, which means answer at 0, comma n minus 1 minus I. N minus 1, n is 3. 3 minus 1, 2 minus 0, 2. So answer at 0 comma 2. Answer at 0 comma 2. So this is a 0th row and this is the second column. So this is 3. Now I becomes 1. So 0 comma 1 comma 1. So first row and first column. So let's add this. Now I becomes 2. Comma n minus 1, which is 3. Sorry, n minus 1, which is 2. 2 minus 2, 0. Okay, 2 comma 0, second row and 0th column. So let's add 7. So now the total sum will be sum of primary diagonal plus sum of secondary diagonal. So which we have done already in our code. Now let's return sum. So our answer is not complete yet. I will tell you why. So let's try to run this part first. Okay, I forgot to close this. Actually, the name has to be same like this. See, it is giving us wrong answer. Okay, I'll tell you why. See, the answer for this test case is correct, and for this test case also it is correct. This one, the second test case. See, 8, 8. But for our first test case, the answer is wrong. The answer, our answer is 30, but it has to be 25. So let's see why it is wrong. So here we have written our primary diagonal sum, which is 1 plus 5 plus 9, and secondary diagonal sum 3 plus 5 plus 7. You can see that in both of them the 5 is repeating, but here 5 is coming only once, but in our sum the 5 is coming twice. So let's see how to eliminate this 5. Okay, so we will write a condition something like this: if row into column is odd, then return sum minus n by 2 n by 2. Okay, else return our sum. Okay, whenever the number of rows and columns, for example in this matrix the number of rows and columns were 3 into 3, the product was coming out to be 9, and 3 into 3 is equal to 9, which is odd. So we will subtract this middle part one time. So n by 2 comma n by 2, which is 3 by 2 comma 3 by 2, that is 1 1 matrix at first row and first column, which is this will be subtracted once, and if it is not odd, then we will return our sum. So let's try to run this now. Okay, see, let's try to submit this. 100% faster.